We grow up believing every planet belongs to a star. The Earth circles the Sun. Mars, Jupiter, Saturn, all bound in their orbits, bathed in sunlight, held in place by the gravity of a parent star. That's just what planets do, except it isn't. Out there in the cold black void between the stars, drift worlds that belong to no one, planets with no sun. No day, no seasons, no warmth from above, just endless night and a slow, silent fall through the dark that never ends. They are called rogue planets, free-floating worlds, orphaned from any star, wandering the galaxy alone. And here's the part that genuinely rewrites your picture of the universe. There may be more of them than there are stars, possibly trillions of them, drifting unseen through our galaxy at this very moment, vastly outnumbering all the planets that orbit suns. For most of history, we didn't even know they existed. Now, we're not only finding them, we're discovering they might be among the most common worlds in the cosmos. And, astonishingly, some of them might even be able to host life in total darkness with no star at all. So today we're going to explore these sunless worlds, what they are, how many there are, how we possibly manage to find something that gives off almost no light, where they come from, and why a planet adrift in the freezing dark might not be as dead as it sounds. Let's get into it. Start with what a rogue planet actually is. The definition is simple and strange. It's a planetary mass object that doesn't orbit any star. Instead, it orbits the center of the galaxy directly, drifting through interstellar space on its own lonely path. Astronomers have a whole pile of names for them: free-floating planets, isolated planetary mass objects, nomad planets, orphan planets, starless worlds. But the picture is always the same: a world cut loose, falling through the dark with no sun to light it or warm it. Try to imagine standing on the surface of one. There would be no sunrise, ever. The sky would be perfectly, absolutely black. Not the dark of our night, broken by a moon and the glow of a nearby city, but a total, starlit-only blackness, with the distant stars hanging cold and unreachable. The temperature would be among the lowest physically possible, plunging toward absolute zero. Any surface water would be frozen rock hard. It is, on its face, the most desolate setting imaginable. A world in permanent, frozen midnight, falling forever through emptiness. And yet, as we'll see, that bleak picture hides a surprising secret. But before the secret, let's grapple with the sheer scale of how many of these things are out there, because the numbers are genuinely staggering. There's even a puzzle in the very definition. There's a related class of object called a brown dwarf, a failed star, a ball of gas too big to be a normal planet, but too small to sustain the nuclear fusion that powers real stars. A large free-floating planet and a small brown dwarf can look awfully similar, both drifting starless through space, and it isn't always obvious which an isolated object is. These wanderers don't just challenge where we look for worlds, they blur the very definition of what a planet is. For a long time, rogue planets were purely theoretical, a curiosity, something that might exist. The first ones weren't detected until the year 2000, but as our methods improved, the estimates of how many there are kept climbing and climbing and climbing. Today, based on surveys of the galaxy, some scientists estimate there could be as many as 2 trillion rogue planets in the Milky Way alone. Let that sink in, 2 trillion. That would mean rogue planets outnumber the stars in our galaxy, and that there could be something like 6 times as many free-floating planets as there are planets bound to stars. In other words, the normal planets we usually think about, the ones orbiting suns, might actually be the minority. The galaxy may be filled, far more than we ever imagined, with these dark, drifting, starless worlds, and we walked around for almost all of human history with no idea they were there. There's a humbling thought buried in this. Our galaxy holds a few 100 billion stars, and 2 trillion rogue planets would be several times that. For every blazing star you can picture in the Milky Way, imagine several dark, silent worlds drifting in the spaces between, never twinkling, never named. The nearest rogue planet to Earth might even be closer than the nearest star. A starless world drifting silently a light year or 2 away, closer than Proxima Centauri, and we'd have essentially no way of knowing it was there. Which raises an obvious and difficult question. If these worlds give off almost no light, no star illuminating them, many of them cold and dim, how on earth do we find them at all? You can't photograph something that doesn't shine. And this is where the methods get genuinely ingenious. The main technique is one of the most elegant tricks in all of astronomy: gravitational microlensing. It works because of something Einstein predicted, that gravity bends light. Here's the idea. Imagine a distant background star, far away, shining steadily. Now imagine a rogue planet drifting, by pure chance, directly between us and that distant star. The planet itself is invisible, but its gravity warps the space around it, acting like a lens. As the planet passes in front of the background star, its gravity bends and focuses the starlight, making that distant star briefly appear to brighten and then fade back over the course of days or hours. We don't see the rogue planet. We see its gravitational fingerprint, written in the temporary brightening of a star behind it. The crucial beauty of this method is that it doesn't require the planet to emit any light at all. It only needs the planet to have mass. So even a cold, utterly dark world betrays itself, just by bending the light of something behind it. There's a second way to spot them too, for the youngest rogues. A planet freshly formed or recently orphaned is still warm, glowing with the leftover heat of its birth. And that warmth shows up in infrared light, the light of heat. So powerful infrared telescopes, the kind that can sense faint warmth across vast distances, can directly spot these young, warm wanderers glowing softly in the dark. This is how some of the most striking rogue planet discoveries have been made, not by their reflected light, because they have none, but by their own residual body heat radiating into the cold. But microlensing, for all its elegance, comes with a heartbreaking catch, what astronomers sometimes call the agony of the method. A microlensing event happens only once. The alignment between us, the rogue planet, and the distant background star is a fleeting, one-time cosmic coincidence that lasts mere days or even hours, and then it's gone forever. The planet drifts on, the alignment breaks, and that particular world can never be observed again. We catch a single, ghostly glimpse, enough to know it was there, enough sometimes to estimate its mass, and then it vanishes back into the dark, never to be seen by human eyes again. For years, this meant rogue planets remained frustratingly mysterious. We could detect that they existed, but we usually couldn't even pin down their exact distance or mass, leaving almost everything about them speculative. That's begun to change in a genuinely exciting way. Very recently, astronomers achieved something that had eluded them for decades. By combining observations of a single microlensing event from telescopes on the ground and a spacecraft far out in space at the same time, they were able to view the event from two different vantage points at once. That parallax, that slight difference in viewing angle, let them, for the first time, actually pin down both the distance and the mass of a rogue planet with confidence. One was detected roughly 10,000 light-years away. It was a breakthrough, turning these ghosts from vague statistical hints into real, measured worlds. And it's only the beginning, because alongside microlensing, the James Webb Space Telescope has been transforming the field with its extraordinary infrared eyes. And what it's finding is rewriting the story. When astronomers pointed Webb at a star-forming region nearly 1,000 light-years away, they discovered several free-floating planets adrift among the newborn stars. But the real shock was a detail. Around at least one of these rogue worlds, Webb detected a disk of dust and gas, the very kind of disk from which moons and planets form. Let that register. It suggests that a rogue planet with no star of its own might be able to form its own miniature system of moons around it. A tiny solar system in miniature, complete with satellites, drifting through interstellar space with no sun at the center. Entire little worlds within worlds forming in the dark. Think about how strange that is. We assume a solar system needs a sun at its heart, but a rogue planet with its own disk could spin off a family of moons orbiting it, held by its gravity, warmed by its heat. A complete, self-contained little system with no star at all. From the surface of such a moon, the sun in the sky wouldn't be a star. It would be the dark, looming bulk of the rogue planet itself, perhaps faintly glowing with its own heat, the only object in an otherwise empty black sky. And the discovery of those disks means this isn't just imaginable. The raw material to build such systems has actually been seen. out there around starless planets. And the discoveries keep getting stranger. In another star-forming region, Webb helped reveal hundreds of planetary mass objects drifting free, far more than theories predicted. Some of them even paired up, two rogue worlds orbiting each other in the dark, which theorists struggled to explain. In 2025, telescopes caught a young rogue planet hundreds of light years away in the act of voraciously feeding, pulling in gas and dust from its surroundings at a staggering rate, measured in billions of tons every second, behaving more like a tiny forming star than a planet. And astonishingly, the James Webb Telescope detected auroras, shimmering light shows like Earth's northern lights, glowing in the atmosphere of a rogue planet, despite it having no star nearby to drive them. The planet's own powerful magnetic field, interacting with charged particles in space, lights up its skies. These are not dead, inert rocks. They are dynamic, active, sometimes growing, sometimes glowing worlds, just without a sun. So where do all these orphans come from? How does a planet end up starless in the first place? Scientists think there are two very different origin stories, and both are probably happening across the galaxy. The first is violent, ejection. Planetary systems are born in chaos. When a young solar system is forming, it's a crowded, turbulent place, full of planets jostling and gravitationally tugging on each other. If a smaller planet wanders too close to a giant one, a Jupiter-sized bully, the giant's gravity can act like a slingshot, flinging the smaller world clean out of the system at tremendous speed. A close pass by another star can do the same. The planet, once a member of a cozy solar family, is hurled into the interstellar dark, never to return, doomed to wander alone. In this picture, rogue planets are exiles, refugees cast out from the systems where they were born. And it implies something poignant. Scattered through the galaxy are countless worlds that once had a sun, once basked in starlight, and lost it forever. The second origin is gentler and in some ways more profound. Some rogue planets may never have had a star at all. They may have formed on their own, directly, the same way stars form, from a collapsing cloud of gas and dust in space that simply didn't gather enough material to ignite into a star. Stars form when a clump of gas collapses under gravity until its core gets hot and dense enough to begin nuclear fusion. But if a clump is too small, it collapses into a planetary mass object that never lights up. A world born in isolation that never had a sun, never orbited anything. A planet that is, in a sense, a failed star. The disks Webb found around some rogue planets support this idea. These worlds may form through their own miniature version of the star formation process, complete with the raw material to build moons. So some rogues are tragic exiles, and others are lonely originals, born free and starless from the very beginning. Now we come to the part that turns this entire story on its head, the secret hiding beneath that bleak, frozen surface. Because a planet with no star sounds like a guaranteed dead world. No sunlight means no warmth, no energy, no life, right? Well, not necessarily. And this is where rogue planets stop being merely fascinating and start being one of the most surprising frontiers in the search for life. Here's the key insight. Sunlight is not the only source of heat a planet has. Earth, for instance, is warmed from above by the sun, but it's also warmed from within. Deep inside our planet, radioactive elements are slowly decaying, releasing heat, keeping our core molten and our geology alive. That internal heat has nothing to do with the sun. And a rogue planet carries its own internal heat with it, wherever it goes. So picture a rogue planet, its surface frozen solid in the interstellar cold. But beneath that frozen crust, heat from radioactive decay in its core could keep things warm. And if there's enough internal heat, that warmth could maintain a layer of liquid water, a hidden ocean, sealed beneath a thick shell of surface ice. The ice on top acts as insulation, a blanket trapping the heat from below, protecting the liquid water from the killing cold of space. If this sounds far-fetched, consider that we may already have an example of exactly this in our own solar system. Jupiter's moon Europa is frozen solid on the surface, but beneath its icy shell, kept warm by internal heating, Scientists are confident there's a vast ocean of liquid water, possibly holding more water than all of Earth's oceans combined. A rogue planet could do the same thing, carrying a dark, warm, hidden ocean through interstellar space. A sealed sea, in total blackness, kept liquid for potentially billions of years by the planet's own internal heat. And where there's liquid water and a source of energy, there is at least the possibility of life. Not life on a sunlit surface, but life in the lightless depths, drawing energy from chemistry and heat rather than from any star, the same way life thrives around volcanic vents on the floor of Earth's oceans, in total darkness, right now. That comparison is our best real-world proof that life doesn't strictly need a star. At the bottom of Earth's oceans, kilometers down where sunlight has never reached, hydrothermal vents spew superheated, mineral-rich water from the planet's interior. And around them, entire ecosystems of bacteria, tube worms, and ghostly crabs flourish in perpetual darkness. They don't photosynthesize. They draw energy directly from the chemicals in the vent water, ultimately powered by the planet's own heat. These creatures don't care that the sun exists. They'd carry on exactly the same if it winked out tomorrow. That is precisely the kind of life that could, in principle, exist in the hidden ocean of a rogue planet, huddled around the warmth welling up from the world's own core, in a sealed black sea that has never seen a sky. There's more than one way a rogue planet might stay warm enough. One striking possibility involves the atmosphere. If a rogue planet held on to a thick, dense atmosphere, particularly one rich in hydrogen, that atmosphere could act as an extraordinarily effective blanket, trapping the planet's internal heat so well that liquid water might survive not just underground, but even on the surface itself. Cut loose from a star, with no stellar radiation to strip its air away, an ejected world could actually hold on to a thick atmosphere quite effectively. Scientists have given the name Steppenwolf planet to such a world. A rogue harboring a hidden ocean, with any life on it living, as the name suggests, like a lone wolf wandering the galactic steppe. It's worth asking the unsettling question directly. What would happen to us if the Earth itself were ejected from the solar system? Within weeks, the surface would plunge into a brutal deep freeze as the sun shrank to just another star in the sky, and the oceans would begin to freeze over from the top down. But here's the twist. That growing ice sheet would itself become insulation. Some scientists have calculated that a thick crust of ice could trap enough of the planet's internal geothermal heat that the deep oceans beneath might not freeze solid, staying liquid in the dark for a very long time. Life on the sunlit surface would be doomed. But life in the deep sea, drawing energy from the planet's heat rather than the sun, might carry on, sealed beneath the ice, scarcely noticing the sun was gone. It's a haunting thought. Even a world torn from its star might not be entirely dead. And the possibilities get even richer when you remember those moons. If a planet is ejected from its star, it can take its moons with it. And the gravitational dance between a planet and its moons creates yet another heat source: tidal heating. As a moon orbits, the planet's gravity stretches and squeezes it, and that constant flexing generates heat through friction deep inside the moon. This is exactly what keeps some of the moons in our own solar system warm enough for subsurface oceans. So a rogue planet drifting through the dark with a moon in tow could warm that moon from the outside through tidal forces, even as the planet warms itself from within. Recent studies modeling moons of rogue planets, even ones flung out into space by the violence of a nearby supernova, find that these moons could sustain subsurface oceans and the basic conditions for life to potentially originate for over 1 billion years. Some scientists now argue that the moons of rogue planets might be among the most promising places to look for life beyond Earth at all. Step back and you realize what all of this means. It shatters one of our oldest assumptions about life in the universe. For decades, the search for life centered on the habitable zone, the Goldilocks band around a star, not too hot and not too cold, where liquid water can exist on a planet's surface. The whole idea was built around a star, But rogue planets throw that out the window entirely. They suggest that life might not need a star at all, that the right ingredients are internal heat, liquid water, and chemistry, none of which require a sun. And if that's true, then the potential habitats for life in the universe aren't just the relatively rare planets sitting in the narrow habitable zones of stars. They could include a staggering number of these dark, drifting worlds and their moons. Some scientists have gone so far as to suggest that planets with subsurface oceans, sealed under ice and warmed from within, might be vastly more common than the rocky planets in the habitable zones of stars. Perhaps hundreds of times more common. The most abundant habitable real estate in the galaxy might not be sunny worlds like Earth at all. It might be hidden oceans in the dark. Of course, we have to stay honest. We have not found life on a rogue planet. We have not even confirmed a subsurface ocean on one. These wandering worlds are so hard to study that for most of them, we catch a single fleeting glimpse and never see them again. Much of this remains, for now, in the realm of careful theory and tantalizing possibility. But that's exactly what makes this moment so thrilling. The science is moving fast, and the tools are about to get dramatically better. The next leap is coming very soon. A powerful new space telescope, designed in part to hunt for exactly these kinds of objects through microlensing, is scheduled to launch toward the end of this decade. It's expected to survey huge swaths of the sky with enormous sensitivity and could discover thousands of new rogue planets, potentially detecting worlds as small as Mars or even smaller, drifting alone in the dark. Other missions are being planned with similar goals. This new telescope is purpose-built for the one job hardest from the ground: staring at vast fields of stars continuously, watching for the brief flickers of microlensing that betray an invisible world. Where past surveys turned up rogue planets a handful at a time, it's expected to harvest them by the thousands, and crucially, to reach down to small, rocky, Earth and Mars-sized rogues, not just the easy giants. For the first time, we'll get a real census, not just that rogue planets exist, but how many, of what sizes. We're about to go from guessing at this hidden population to actually mapping it. So the next time you picture our galaxy, that glittering spiral of hundreds of billions of stars, add something to the image. Fill the vast black spaces between those stars with worlds. Trillions of them, silent, sunless planets falling endlessly through the dark. Some of them exiles cast out from dead and distant homes. Some of them lonely originals that never knew a star. Most are frozen tombs. But some, perhaps, carry warm, hidden oceans beneath their ice. Sealed seas that have been drifting through the blackness for billions of years. And in that lightless water, who knows what might be waiting. The galaxy is not a tidy collection of stars with planets neatly attached. It's an ocean of darkness, full of drifting, masterless worlds. And we are only just beginning to see them. They were always there, uncounted, unlit, unbound, falling silently through the night between the stars, long before we ever looked up and noticed. And now that we know to look, the dark has never seemed so full.